So where we left off in the last video is receive was working, but I was waiting for a replacement FST3257 from DigiKey. It's just arrived. So what I'm going to do is I'm going to install one of them back in this spot here, check the voltage regulator, make sure we don't have that short again, and then we can proceed. Okay, the new IC's back on the board. Or rather it is on the board. I've tested to make sure that we don't have any short to ground again. Let me just confirm that. So that was from pin 16 to ground, so we don't have that. Pin 15, however, should go to ground. There we go, and also actually pin 8 on the other side. That I've already checked that. So what I'm going to do now is proceed on to the phase shift network, test that, and keep going on. So I'm getting ready to put the phase shift component onto the board, but just a quick explanation of the components. So this is the phase shifter right here, familiar configuration with the dual op amps. This is a simple sort of buffer amplifier here. There's no gain here. There's only attenuation, and that attenuation is controlled by this pot here. So I'll put all this together, and then for testing, so what I should expect to see is I'll inject an audio signal here, and I should be able to extract the 0 and 90 degree signal. I should see that here, and then here I should see 180 and 270. So I'll put the scope between here and here, should see a 90 degree phase offset, and then I'll put the scope between here and here, and here and here, and I should see 180 degrees offset between those two. So let's put this on the board, and we'll come back and do some testing. Okay, so that's all installed and getting ready to test here. So here's those three ICs, all three dual op amps. So these are the two that are involved in the phase shifting. And then this is the buffer amplifier, and then this is the pot that you use to control the input attenuation coming in from the audio in signal. Just one thing to note, I'm sure this is in the manual, but I must have spent 20 minutes looking around for C12 and C13. They're the 0.047 microfarad 1% caps, and they're actually SMD caps, and they're already on the board. So had a bit of a panic there because I don't have any 1% 0.047 microfarad caps. The rest of it's pretty straightforward. For the great majority of these are 10 kilo ohm resistors. The one exception is this 60.4 kilo ohm resistor right here. So anyway, let's get ready to test this, and we'll be right back. Okay, so let's start doing some probing around. The first place I'm going to probe is right here. So I'm going to put WSJTX in tune mode, inject the signal in here, and then here we should see an output sine wave. But also by adjusting this pot here, we should see the signal increase and decrease. So I'm going to do that. Bear with me. Let's get you up on the oscilloscope here. So I'll put it probing pin 1. No signal at the moment, so let me turn tune on. There we go. There's that. Whoop. Sorry about that. There's that signal. And now let me adjust the 10K trim pot, and you should see that signal increase and decrease. So that confirms the first part of the circuit is working fine. So what I'll move on to next is checking the output of the phase shift network. So I'll be probing right here, and we should see a 90 degree offset between these two signals. So that's coming right up. Okay, so I have my two oscilloscope probes right here and right here on the legs of those two 10K resistors, and it's those two 10K resistors R14, R19, and so I'm probing here and here. So let's just pan up to the oscilloscope, and you can see the output yourself. So just clicking on tune, and there's the 0 and 90 degrees signal. So that means the output, at least at that point, is correct. So what I'll do now is I'll move down to here and here, and these two guys should also be 90 degrees out of phase with one another. Okay, so this is probing the other outputs, the 180 and the 270, and this is on resistor R20 here, so that's a handy one. But this leg of R15 is not connected to the output, so what you have to do is use this resistor, this hole right here, and it's currently unpopulated, so just pop that in there, and then let's move over to the oscilloscope, check that out. I'll click on the tune button again, and there's those two signals 90 degrees out of phase with respect to one another. So the final test now is to confirm that between here and here is 180 degrees. So these should be antiphase, and then these two guys should be antiphase. So I'll keep this one at the moment, and then I'll pull the other one back to here. We should see 180 degrees out of phase one another. Okay, so I've got a probe on R14, and I've left the other probe in that hole of the resistor R44, the top pin there. So let's go back to the oscilloscope, confirm that they're 180 degrees out of phase with one another. And as you can see there, that's 180 degrees out of phase with one another. Now, just to be anal, the final test, even though we can sort of derive it from the rest of it, is to confirm this point here and this point here is also 180 degrees out of phase. So I'll do that right now. Here's the test setup. I've got this leg of R19, this leg of R20. And just moving back to the oscilloscope. Let's hit the tune button. And there you go, 180 degrees out of phase with respect to one another. So that confirms basically that this section here is all working. So we've confirmed that. Now the next portion is to basically install all the 51 ohm resistors between the phase shift network and the Taylor mixer. So you've got some 51 ohm resistors to install. You've also got a variety of 100 nanofarad capacitors that you've got to install between those two. And then there's the testing of this component here. So hopefully I didn't blow that other FST3257 as well. I did actually order more spares though, so if I have, I'll pop that off. So once we've got all that installed, we'll be able to inject an audio signal here, and then we should be able to confirm here what we should see on the output is that one of those sidebands is suppressed. That's the hope anyway. So more to come. Okay, so I'm going to build up the resistor and capacitor network to the FST3257s. I'll also include building the RF combiner and this amplifier right here. And then what I'll do at the end of that is probe right here, and we'll see what we see. Now obviously at this point you should have the RF signal with the one of the sidebands suppressed. So for FT8 that's typically upper sideband, lower sideband suppressed. So I'll probe here and we'll see what we see. And before I forget it, I've got don't forget this marked right here. I'll install this this transistor right here. I definitely don't want to forget to do that. So anyway, I'll install all that and come back. Okay, so I've installed transistor Q1, which goes right here, along with the resistor. And what I thought I'd do is I'll just test to make sure that on transmit, I don't get any signal coming through the receive path. So I've got the radio hooked up to my signal generator as I did before. I've got the input coming into the phaser coming from my PC. I've got the output going to a speaker. So let's basically just turn that up. So there's the tone that I'm receiving from the all the way from the signal generator through the mixer and so on. So when I hit the tune, you'll hear that signal goes off. So that's that transistor turning on and routing the receive path to ground. So that bit, it works. We can move on with the next part. Okay, so I've installed all the resistors and capacitors between the phase shift network and the FST3257s. I've also included this this preamplifier here, the 2N4401, and its emitter resistor as well. So what remains in this section is the RF combiner transformer, which goes right here. And just let me pan down. This is one of the things I really like about this kit, just the little touches here. So that transformer is wound bifiller, but the kit designers have included the bifiller wound number 28 enameled wire with it. So it's just a nice little touch like that, really good. There's the T3743 on which it is wound. So what I'll do is I'll wind the 11 turns required on that. Just let me check. It is 11 turns, I think. I want to get that. I want to get that right. Bear with me. Sorry, it's 14 turns of the bifiller. So I'll go ahead and wind that, and we'll come back ready to install it. Okay, so there's the wound toroid with the enamel removed. The usual method of just putting a big solder blob on it. So I should get continuity between the two reds. Bear with. There we go, continuity between the two reds. Also continuity between the two greens. But no cross continuity between the red and the green. You can see there's no cross continuity. What can happen, particularly with these FT style toroids, is you can score the enamel on the wires and create a short on your toroid, and you want to make sure that that isn't the case. Once it's in circuit, because the two windings are actually connected, there's no way you can check it once it's in circuit. But anyway, that looks good, so I'll install it in the circuit and we'll continue. Okay, so that's T1 installed, the FT3743 bifiller wound. The installation, make sure if you do red, green as the order on this side, you follow that same order on this side, red, green. So it doesn't really matter which way, but if you do red, green on this side, it has to be red, green on the other side. If you do green, red on this side, it has to be green, red on the other side. So what I'll do now is I'll just check continuity. So just checking continuity, what I should have is pin 7 of U5 and pin 7 of U6 are both connected to the base of that transistor Q2. So I'll go ahead and check that. Let's just move over here. That's going to be a bit hard to do this behind the camera, of course, but let me get that one of the probes on the base of that transistor. Okay, we got that there. Bear with. So pin 7's right here. So continuity there. That's ground there, so no continuity there. And then pin 7 of this guy. Alright, so that means that we have continuity through T1, and we're basically now ready to move on to actually testing to see if the output signal has the lower sideband suppressed. So that's coming right up. Okay, so this is the big moment. So just to describe the test setup I've got going here. So I have a BNC connector, you can just see out of focus there, and the center pin is connected right here on this capacitor Q16. This is the ground pin here, and then I've got this going off to my spectrum analyzer, which I've got running over here. Let me pan up there. Sorry, there's a lot going on here on the desk here. So, big moment when I click on tune. Success. So you can see there. So the middle one is the carrier. So that's at 14074. This is the upper sideband signal, and the difference between here and here is the frequency that I'm transmitting in WSJT. So I've currently got that set to 1600 Hertz. So if I move that up, let's say to 2500 Hertz, you can see you can see those two signals separate apart. So let me just get to the peak of that signal there. So that's at 14.076507. So in other words, there's a tone at 2.5 kilohertz above 14.074. And then if I go left peak, so there's the carrier of 14.074. And this is the lower sideband on the other side. And you can see, importantly, that the lower sideband is suppressed. Now, at this point, let's just see what that suppression is. 49.25 dBs. Go back, and 28.24. So that's about 20 dBs of suppression. One of the things that I noticed is when I was at 1500 hertz, the lower sideband suppression was better. So here we have, let's just go to the peak, 28 dBs again, and then if I go to the lower sideband, left peak, 65. So I'm getting better lower sideband suppression at when WS-JTX is emitting a 1500 hertz tone. So 28 to 65, that's over 30 dBs of suppression. And let's just go down lower for chuckles, down to 500 hertz. And you can see again there that the lower sideband suppression is reduced at that point. So it's kind of interesting. There's 1 kilohertz. The good thing is though that that sideband suppression is actually working. You can see there, lower sideband is suppressed. There's the upper sideband. That's exactly what we want. What I'll do now is I'll probably wrap this video right now. The next phase is to build the amplifier part of this. So once we've built the amplifier part of this, we can actually test the final signal out of this, the final amplified signal. Do the same thing with the spectrum analyzer. I'll have to, I got a 20 dB attenuator on that. I'll have to put a bigger attenuator on that to test it. So that's good, success. I was a little worried whether that FST3257 would actually work, and that honestly it might be one of the reasons why the suppression isn't as good on higher and lower frequencies, because I do have effectively two different 3257s in circuit there. The original one provided plus the replacement one I had. So that could be the reason, not quite sure. I'm sure I can do some more experiments to find out. Anyway, this is a wrap for now. In the next video we'll put in the final amplifier and get this thing on the air. Just a quick after note, again for those of you not familiar with WS-JTX, to change the frequency that WS-JTX is transmitting on, you use this waterfall. You hold the control down and then click on the frequency that you want, and that keeps the transmit and receive frequencies the same. You can operate WS-JTX in so-called split mode, where you're transmitting and receiving on a different frequency. But as you can see, so let me control click on, well, let's control click on around about 700 hertz here. And then if we go over to the spectrum analyzer, bear with, and hit the tune button, these two signals here should be 700. This should be 700 hertz apart from this, and 700 plus 700, 1400 from this. So let's just try the peak. So the peak is at 14.0781. It's actually 800 here. So, and then down lower, bear with, and then that's 800 hertz below the carrier. Again, with 800 hertz, let's just check that lower sideband suppression. So 28 to 49, so about 21 dBs of suppression. I'll have to check the manual and see what specifically the suppression is that they're aiming for. But anyway, that's a wrap for now. I'll come back in the next video and do the final amplifier.